Okay, hello everyone. All right, so let's talk about comparing strings. All right, so far we know how to compare primitive data types: int, float, doubles, chars, bytes, shorts. We know how to compare them when we can compare them with relational operators. So for example, we can create an int variable, and I can call it, let's say, number1, and initialize it to the value, let's say 5. And then I can create another int value, I'll call it number2, and initialize it to, let's say, 6. Now we know that we can compare these two numbers with an if statement with relational operators. This way. We can say, for example, if number1 is less than number2, then print out the message saying that we can say all right, so let's use the content of the variable. We can say number1 concatenated with a string is less than concatenated with a value of number2 is less than number2. Right? Else meaning if number1 is not less than number2, else then let's print out the message saying that number1 is not less than number2. So let's compile this and then run, and it says 5 is less than 6, and that's true. If I change 5 to 7, compile this and then run, and it says 7 is not less than 6, and that's true. 7 is not less than 6. So we know that we can compare primitive data types this way, right? With relational operators. We can use a less than sign, we can use a double equal sign to compare. Not the single equal sign. The single equal sign assigns what's on the right to what's on the left. Double equal sign compares what's on the right with what's on the left. We can use greater than or equal to. We can use basically relational operators to do that. But when you're comparing strings, it's a bit different because strings are a bit special. Strings are also data, but then they're special data. And the special data, so basically they are special data called objects, right? So let's talk about that. Remember we talked about it a little bit when we were talking about declaring string variables or string object and all that stuff. We'll go into classes and objects into detail, but strings are a bit special. All right, so when you're creating a string, the process is you start with string, right? The string class, and then we create a string class type variable. Okay, it's a variable, but it's what's called a class type variable, because we are creating it from the string class. So let's create a class type variable, for example. Let's call this name1. Right? So what we've done is we've created a string class type variable from the string class. Think of the string class as just a definition of something. Think of this as a parent and think of this as a child. Right? We are creating, so the parent is giving birth to a child. Right? This string, class has some information about itself. It has some functions, right? It can do certain things, and it has information about itself. When that child is born, when this parent gives birth to this child automatically has that same information about itself, and it has the same functions, the same things it can do. So this is a class, and this is an object. Well, it's not an object. It's not an object, right? Hold on. Let's slow down there. But it's what's called a class type variable. That's going to hold something, right? It's not the object yet. Okay, so let's slow down there. It's not an object yet. It's a class type variable that's going to hold something. So hold on. So now let's go ahead and create the string object itself. So I'm going to put in double quotations and create, let's say, the name Kakra. That's my name. Semicolon. Now this is the string object. This is the string object. Now you may think that this class type variable, again, we call it a class type because we created it from this class. You may think that this class type variable holds the string Kakra directly. It doesn't. That's why strings are a bit special, right? This is the string object itself. You may think it's just regular data, right? Why do we call it object? It's an object because this is the object itself, right? We've created the object, and because we've created it from the string class, it has the same information as the same information in the string class, and at the same time it has functions that it can do. It can do things. You can think of it as superpowers, and at the same time it has information about itself. This variable, the purpose of this variable is to kind of refer to the string object. It doesn't hold the string object directly, but it holds what's called the memory address of the string object. This string object is sitting somewhere in memory. It's somewhere in memory, stored somewhere in memory, and this just holds the address of it, right? So when you use this, you're kind of referring to the object. But this, it's very important to know that it doesn't hold the object directly, all right? So because it doesn't hold the object directly, if I create another string class type variable and I call it, let's say, name2, and I initialize it to the string key, for example, right? They used to call me this when some people still call me this, right? It's like one of my nicknames. All right, so because they don't hold the string object themselves and they hold the memory addresses of these two strings, it's not a good idea, right? You don't compare the variables, the class type variables, using relational operators, right? Because if you do something like this, if name1 is equal to, now I'm using double equals to compare, right? To compare what's on the right to what's on the left. If I use one equal sign, I'm assigning what's on the right to what's on the left. So double equal sign, we want to compare here. So if you do something like if name1 is equal to double equal to name2, let's print out the message saying that they are equal, right? They are equal. Else, if name1 is not equal to name2, then that means they're not equal, right? So let's print out the message saying that they are not equal, right? So let's compile this and then run it. So it says they are not equal, right? It's true, they're not equal, but this is not right, because you may think that it's comparing these two string object and saying they are not equal. It's saying they are not equal not because these are different. It's saying they are not equal because it's comparing the memory addresses. It's comparing two different memory addresses and saying they're not equal. That's true because this has a different address. Remember, these variables, these class type variables they hold the memory addresses of these two objects, right? They are only referring to it. If you kind of use this, you're referring to the string object. This is the object directly. It's comparing the memory addresses, and it is comparing two different memory addresses, and that's why it's saying they're not equal and not the strings themselves. So this can mislead you. That's not the right way to compare string object. String object, again, are special. They have information about themselves, right? This is the object themselves, the object directly. This is what was created from the string class. This is what was created from the string class. These are just referring to them. They hold the memory addresses, right? So because they have information about themselves, like information, for example, this string object has information. It has the number of characters it holds. It knows it. It's special. Like if you store primitive values, if you store just an int in an int variable, that's it. It cannot do anything special. That variable will just hold that int value. Or that variable will hold, for example, a float. If you create a float variable, that variable will hold a float. That's it. It cannot do anything special. But this value over here is kind of smart because it was created from the string class. It's kind of smart. That's why it's called an object, because it knows how many characters it holds. And on top of that, it can do things. It can perform operations. Now, those operations are what are called methods. Now, we'll talk about methods in the future, right? But what a method is, one or more lines of code that is wrapped up together with curly braces and given a name, right? The people who developed the the people who developed the Java language, they've already written some code for us because they don't want us to write it ourselves, right? They don't want us to go through the pain of doing it again. We can do it ourselves, but they've done it for us because they realize that, common things we can do. We'll be doing some common things that we don't have to do over and over again. So they've written this code for us. They've wrapped it up with curly braces and they've given it a name. And they are saying that, okay, if we want to do any of the things that they've written, any of the code that they've written, all we have to do is just use the name of the method, right? So these objects have functions and they have these kind of operations, right? Called methods. And when you apply the method to the object, it performs that operation on that particular object. On top of that, these objects also have information about themselves. Again, like I said, they're smart enough to know the number of characters they hold, and they can perform all kinds of operation on themselves. So we cannot use relational operators to compare strings this way, But we can use some of the methods to compare strings. So we use these methods on the object directly. Okay. Now again, we are using this just to refer to this object. So when we are using name1, we're actually referring to this. Just know that this is just referring to, this just holds a memory address. And that's why we have to use a method to perform these operations on these objects directly. So there's one method called equals, but before you access it, you have to use the access operator, which is a dot, a period, or a dot. It's a dot operator or the access operator. We are accessing some of the functions, some of the superpowers or the operations. These superpowers are called methods. We're accessing some of the methods of this name1 string object, right? And one of them is called equals. Some of these methods, right, before they work, before they kind of execute, they need extra information to work. So again, a method is one or more lines of code wrapped up together with curly braces and given a name. So the people who created the Java language, they've written some code. It could be one line, it could be multiple lines. They've written it for us already, and they've given it a name of equals. And they're saying that if you want to compare to a string, just use the name, just mention the name, and the code will run for you. You don't have to type it all over again. If they didn't do that, then we would have to type the code ourselves. But they've done that already. They said if you want to compare to string, apply that method, apply that superpower, which is called a method, to the object directly, okay? And then it will do that function. But equals, these methods, sometimes they need extra information, right? So equals needs something, okay? It needs another string object to compare with this string object. Name1 refers to this. So it needs another string object to compare with name1. So I'm going to pass in another string object, which is name2, right? And so equals, you've given it name2, and it will go ahead and compare. So the code that the people who created the Java language, the code that they wrote, it's basically taking this string object and comparing it with this string object over here. And if they are equal, this entire statement, this entire line here, will result to true. If they are not equal, then it will result to false. We know that for an if statement, if what's in the parentheses over here results to true, then what's in the if block will run. If what's in the parentheses over here doesn't result to true, then what's in the else block will run. Right? So equals takes an object, a string object, and compares it with the object that you're applying the equals to. Okay, you're applying it to. It takes this and compares it with that. And if it's true, sorry, if they're equal, then it will result to true. And if what's in the parentheses over here results to true, this will run. If not, then this will run. Right? So let's compile this and then run. And it says they are not equal. Now it's really comparing the string objects directly. If you use relational operators to compare these, you are not comparing the string objects directly. You're comparing the memory addresses of these two string objects. Right? But if you use a method, if you're applying this method directly on the object, okay, these objects have superpowers. Some of these, one of the superpowers they have is equals, and you're applying it directly on this object. It takes in another, right, and then compares. So you could do something like this. Now it's really comparing them. It's comparing this string object, and telling you they're not equal. And it's telling you they're not equal because they're not equal right here. If you make them equal, right, and you compile and you run, now it says they're equal. We can also apply the same equals method on the string object, because again, when you create any string object from the string class, automatically, because this is the parent and this is the child, you can think of it that way, it kind of automatically, once it's given birth to, it kind of has the same features or characteristics of this class, right? This class has the same thing, it has the same information about itself, and it has superpowers. But when it gives birth to an object, right, again, these variables are just referring to them. When it gives birth to an object, these objects also automatically have the same information about themselves, and they have the same superpowers or operations or functions called methods. All right, so we can apply the same equals method on this name2, right? This name2 points to this, on this object here, right? So name2, we are using a dot operator to access the superpowers that it has, which is really the methods that it has. One of them is called equals, and it needs something to compare with this, right? So in this case, we want to compare name1 with name2. We want to compare name1 with name2, and if it's true, then it result. If they're equal, then it will result to true. Okay, and if what's in the If what's in the parentheses over here is also true, then this will run. If it's not true, then this won't run. Compile this and then run, and it says they are equal. When I change, let's say name1, let's say to khaki, compile this and then run, and it says they are not equal. So now it's really comparing it because we're using equals, the methods directly. All right. Now, I mentioned that these, right, are just the memory addresses, okay, of these two string object. Right. You can also use the objects directly. This is just a memory address. We are using the methods, right? So the method is kind of doing everything for us. You can also use a string object directly. You can say if the string khaki dot equals. So khaki, you are applying equals on this string object directly here, right? This is the real string object here, right? So we are applying this method to it, the superpower to it, right? And it needs something to compare it with. In this case, I want to, well, khaki happens to be a string here. I want to compare it with name2 because, you know, khaki, this name2 is kakra, so they're different, right? So when I do this and I compile and I run, it says they're not equal. At the same time, over here also, you can give it the string object directly and say, is khaki equal to kakra, right? When I compile and run, it says they're not equal. If I change this to khaki, compile and then run, it says they're equal. I'm kind of passing over here the string object directly, and over here I'm applying this method on the string object here directly. You can do that, or you can use the class type variables, or what's called a reference variable. It's called a reference variable because it's a variable that refers to the string object. It holds a memory address of the string object, and it was created from the string class. Okay, we'll talk more about classes and objects, so don't worry. We'll talk more about methods, so don't worry. All right, so that's one of the things you can do. Let's go back to name1, not the string, name1. Sorry, the class type variable name1 equals, and let's go to the class type variable name2. All right, so we know this works, right? Compile this and run, they're not equal because now we're comparing these two string objects. So the way you, for example, check to see if name1 is not equal to name2. Now we're checking over here to see if name1 is equal to name2, right? The way you'd say name1 is not equal to name2 is by using the exclamation sign. Now we know this already from the not logical operator, right? That's the exclamation sign. So it just basically reverses a logical expression, or a Boolean expression, or a Boolean value. It changes it to the opposite. If it's true, it changes it to false. If it's false, it changes it to true. So the way we would say if name1 is not equals to name2 is by placing the exclamation sign in front of it here. Now you don't have to surround name1 dot equals name2 with parentheses here. Why? Because this entire line here, this entire statement here is together, because the dot over here is kind of joining all of them together. It's together. So you're kind of applying the exclamation sign in front of one thing here. So you don't necessarily need the parentheses, right? All right. So what we want to say is if name1 is not equal to name2, then let's print out yes, name1. So let's print out yes, they are not equal. Okay, if name1 is not equal to name2, they are not equal. Else, that means they are equal, right? So let's print out they are equal. Okay, if name1 is name1 is not equal to name2, then they are not equal, right? Else, that means they are equal, so print they are equal. Let's compile this and then run, and it says they are not equal because these two objects are not equal. When I change this back to kakra, compile and run, and it says they are equal. You can also surround it with parentheses like I was saying. The entire thing with parentheses like I was saying, and it'll still work the same. Run, it says they are equal because these are equal. When I change, let's say this to khaki, compile and then run, now it should say they are not equal. But I'll remove the parentheses just so it doesn't look too confusing, but just know that you can if you want. This is just one thing, so you don't necessarily have to, but I'm the kind of person who will surround it with parentheses just to keep things very organized, as long as you understand it and it's not too confusing to you. All right, so I think that's about, that's one of the methods. Okay, that's one of the methods. Okay, again, the string object or the string class, same thing. The string class has so many methods or so many functions you can perform on this, right? And so anytime you create an object, it has all these methods and all these functions that you can apply on the string object directly. So this is one of them, right? And in the next video, we'll look at another one, and then we'll learn more string object as we go, right? So I know this was long, and I know this was may seem a bit confusing, but I hope you get the idea. We'll talk more about object. We'll talk more about methods and classes and everything. But at least I hope you have an idea, right? If you have any questions, comment down below, and I'll do everything to respond to them. Thank you very much for watching. Take care of yourselves, and I'll see you next time with the next video. All right then. Bye bye.